Okay, now let's continue by the third subtopic, which is 7.3. The topic is gravitational force and field strength. All right. So, according to the learning outcomes, students should be able to define and use escape velocity, also derive and use equation for satellite motion, okay, involving the velocity and period. Okay, so how to get the equation? So remember, you need to know how to derive the equation, because according to the learning outcome, you need to learn this. All right, so they may ask you to derive the equation. All right, so what do we have? What is escape velocity actually? Escape velocity, the symbol is VE, defined as a minimum velocity required by a mass to escape completely from gravitational field to infinity in outer space. Okay, seems like there is no more effect by gravity lah, right? Because the object escaped already completely from the gravitational field. All right. So derivation of escape velocity, okay, we may use the principle of conservation of energy, where sum of E initial equals to sum of E final. So initially, what do we have? K initial, also U initial. Finally, still the same, K final and U final. All right, so initially we just start from the planet. Okay, we are trying to launch the object with escape velocity. So for the kinetic energy, the equation is half mv squared. So v is our escape velocity, which is ve. Okay, we just launch this object using the escape velocity, and then the potential energy now is negative gmm over r. This is our gravitational potential energy. All right, the object is located at a point where the distance between the point and the center of the planet is r. Okay, and finally what happened? K and U become 0. Why? Because the object doesn't affected by gravitational field anymore. So seems like the object is floating already. There is no more speed, so no more K, and there is no more gravitational potential energy. Okay, because free of gravitational field strength. Okay, so finally the energy becomes 0. So based on that, by rearrange the equations so that you will get the equation to be like this. Okay, escape velocity equals to square root of 2 gm over r. Again, what is g? Just a constant, universal constant. M is the mass of the planet, and r is the separation between the object and the center of the planet. All right, so ve is our escape velocity lah. Or we may change the equations to be like this. Okay, v escape equals to 2gm over r. Okay, what does it mean? The object just start from the surface of the planet, because we are talking about r. So capital R here representing the radius of the planet. Seems like the object start from the surface lah, of the planet. All right, and then gm equals to gr squared. Okay, how do you get this? All right, from the equation of ag or g equals to gm over r squared, isn't it? Okay, so by rearrange this equation, then you will get this. So we just substitute this gm into this equation so that you will get this. And against r and r squared, they are cancelling each other, giving you v escape now, escape velocity equals to square root of 2gr. Okay, so for any test mass which is on the Earth's surface, where r equal to capital R, the equation just be like this lah. Okay, so as we know, g here is a constant on the Earth's surface. G equals to 9.81. So we just substitute into this equation, and r is the radius of the planet, and then you will get the escape velocity directly. Okay, Okay, so this is the equation lah, the escape velocity equation. In term of small r, in term of capital R, by giving you g constant, also mass of the planet, which is constant too, or by giving you gravitational acceleration g and radius of the planet, we may use this equation directly. Okay, now lastly, let's discuss the way how do we derive the equation of tangential velocity. Okay, what is tangential velocity? Alright, so by considering a satellite of mass m traveling around the Earth of mass m, radius r, in a circular orbit of radius r, with constant tangential or orbital speed v as shown below. Alright, so this is the planet and this is the satellite. The satellite just orbiting the planet or Earth now. So separation between satellite and the center of the planet now is r. Okay, so how do we find the tangential velocity? So the green vector here now representing the tangential velocity, okay, which is tangent to the circle. All right, so how do you get this? All right, so as we know, the satellite attracted by the planet, so the force exerted on the satellite is Fg, which is our gravitational force. All right, at the same time, the satellite now is moving in circular path, so we are talking about a circular motion. So for any circular motion, the net force exerted on the object now is Fc. So based on this chapter before, okay, sum of F equals to F net. So F net now equals to Fc. All right. So this is our F net. For any circular motion, F net equal to Fc, and the force exerted on the satellite is Fg. So Fg equals to Fc. All right. So Fg is gmm over r squared. Fc equals to mv squared over r. So r and r squared here cancelling each other. Okay, also mass of the satellite giving you v to gm over r square root here. So remember, capital M representing mass of the planet, small m representing the mass of the satellite. And now mass of the satellite cancelling each other. So what do we have? Just mass of the planet only. So the orbital velocity equals to square root of gm over r, where r is the separation between the satellite and the center of the planet. Okay. Okay, next, let's discuss about the derivation of period. As we know, the object is moving in circular path, so to complete one circle, the time taken is period, isn't it? So how do we get the equation of period? So for any circular motion, the period of the revolution, the symbol is capital T, of the moon is given by T equals to 2 pi r over v. Okay, substitute v equal to 2 pi r over, okay, so by rearrange the equations, v equals to 2 pi r over t. Okay, we just substitute into the equation of orbital speed before, which is square root of gm over r. So v and v equal to each other, so that 2 pi r over t equals to square root of gm over r. You will get this by rearrange the equations, and then you will get period equation, where period squared equals to 4 pi squared r cubed over gm, or based on this, okay, wait, what do we get now? T equals to square root of 4 pi squared r cubed over gm, or you will get 2 pi square root of r cubed over gm. So this is the equation of period. Okay, so by completing one complete circle, the times taken is capital T, which is period. So this is the way how do you get the equation of period. All right, so you may memorize this equation, or maybe you may derive it. It's quite simple. All right. Okay, I think that's all for chapter 7. See you again by chapter 8. Bye. Assalamualaikum.